billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. I welcome you back to this channel today. We have a problem 3b. We solved problem 3a in the previous class. Now let us read the problem. It says find the resultant of the following displacement. You have two displacement vectors. I wrote them in red ink so that you can identify them easily. The first displacement vector has a magnitude of 2.0 meters and its angle, its direction is 40 degrees. And the second displacement vector is twice as long as the first, with a magnitude of 4.0 meters and its direction is 127 degrees. The angles being taken relative to the plus x-axis as is customary. Okay, before we begin, we need to remember the quadrant system in mathematics. In mathematics, you see we have four quadrants. If this is 0 degrees, we measure in an anti-clockwise direction. This is the first quadrant, and the total angle in the first quadrant is 90 degrees. Each quadrant has 90 degrees angle. So the second quadrant here is also 90 degrees. So at the end you have 180 degrees. The third quadrant here is also 90 degrees, so you add it to this, you have 270 degrees. And then the fourth quadrant also 90 degrees, you add it to 270, you get 360 degrees. Now we have to decide, we have to understand which quadrants do we have our vectors. The first vector, look at its direction, 40 degrees. 40 degrees is more than 0 degrees, but it's not up to 90 degrees. It's less than 90 degrees, and as such we say that it is in the second quadrant. We have our vector in the second quadrant. Then the second one, the angle is 127 degrees. 127 degrees is more than 90 degrees, but it is less than 180 degrees. So this means it should be in the second quadrant. Hence, the first vector is in the first quadrant and the second one is in the second quadrant. To solve this problem, you have two ways of solving the problem. Number one, you can draw a single xy plane and draw the two vectors there, do the resolutions and find the resultant vector there. Or alternatively, you can draw two separate xy planes, one for each vector, then you do the resolution. I prefer the second because the first usually confuses students. Without any delay, let us draw this, the first vector. I'm going to draw the xy plane for the first vector, and I will just draw the first quadrant since we know that it is in the first quadrant. So we are going to have something like this. Okay, this is my plus x and this is my plus y, and we know this is 0 degrees. Okay, then we can measure the we know that the angle is between 0 and 90 degrees, 40 degrees. So if we measure from 0 all the way to somewhere here, okay, then this should give us I'm not measuring exactly, okay, I'm only sketching, and this is what you should do as well. So we have this angle here, okay, this is our first vector. Its magnitude, as we can see, is 2.0 meter. It means the length of this line from here to here is 2.0 meters. Now remember what we said in the class. We said that whenever a vector is inclined, it has component along vertical, it has component along the horizontal. The component along the vertical, you have a choice. You can draw it here, or you can bring it here and join it with the with your vector here. So I prefer joining it with the vector so that I will have a right angle triangle when I do that. So I'm going to draw Okay, as you can see now, I have drawn my vertical component, okay, and then the horizontal component, the effective value of this vector along the horizontal axis is directed along the positive x-axis. So it is here. This is my horizontal component, okay. Now the angle here, remember, is 40 degrees, so I can write my 40 degrees angle here. Next, I will now draw the second vector in a separate xy plane, and since it is on the in the second quadrant, so I will draw it. I will draw the second quadrant to make it large because it's the one that I need. Okay, great. This is my uh, plus y, and this is my plus x. Okay, if I measure the angle all the way from here, this is 0 degrees and this is 180 degrees. Remember, this is my negative x and this is 180 degrees. So if I start from 0, I will go all the way to here and stop somewhere here because my angle is not up to 180 degrees. So I stop here. Then I will now draw my vector. My vector, uh, yeah, this is my vector, and the magnitude of the vector from the problem, you can see that it is 4.0 meters. So it means the length of this line from here to here is 4.0 meters. Okay, and the angle here is 127 degrees. This is interesting. Now I can draw the vertical component either here or here, but I like drawing it here so that I can have all my vectors combined together to have a right angle triangle. So I will draw my vertical component here, okay. Then my horizontal component is directed along the negative x-axis. So I will also draw it here. It starts from here to the tip of the vertical component. So this is my vector, vertical component, horizontal component, but I need to know this small angle. Okay, this is a right angle triangle. To get this small angle here, I will say 180 degrees minus 127 degrees, and this is 53 degrees. Okay, now the next thing I'm going to do is to get the horizontal component, then vertical component, their magnitude. So to get, how do I get this one? The first thing you should remember is that this is directed along plus x, so your value here is positive. So you take this 2.0 and you multiply it by the cosine. Remember, cos 40 degrees. Horizontal component always use cos, vertical component always use sine. So let me go there and get my horizontal component here. Is in the direction of negative x, so this should be negative. Then I take my 4.0 and I say cos 53 degrees, that's my angle. Then let me come here for my vertical component. This is directed along the plus y, so it will be positive. So I will say here I have plus 2.0 sine 40 degrees. The angle is 40 degrees. For this one, I will say plus, also remember, directed along plus y. If it is directed downward, we have to put a negative sign. So 4.0 sine, the angle here is 53 degrees. Interesting. The next thing we are going to do is to get the total of this horizontal component. So I'm going to say S sub x, meaning the sum of all the vectors along the x-axis. S reminds us that this is a displacement vector. This sub x tells us that we are adding vectors along the x-axis. So for this one, we have plus 2.0 cos 40 degrees, and then for the second one we have minus a 4.0 cos 53 degrees. So this will now be, this is equal to, then you now bring your calculator and press 2.0 cos 40 degrees. Okay, 2.0 cos 40 degrees. This correct to two decimal places. This is 1.53, and remember your vector is measured in meters, so I have meter here, then minus 4.0 cos 53, and this will give me 2.41, approximately 2.41 in meters. Now I will set I will subtract these two now. 1.53 minus 2.41, and this will give me negative 0.88 in meters. Remember, a vector can be positive, negative, or zero. So this one is negative. It means the result is directed along the negative x. Okay, so then we have s sub y, those that are vertical. Those that are vertical, if you look at them, they are all positive. So I have plus 2.0 sine 40 degrees, plus again this one 4.0 sine 53 degrees. Interesting. Now this is equal to, I will now take my calculator and say 2.0 sine 40 degrees. This will give me 1.29 in meters, plus then this one 4.0 sine 53, and this will give me 3.19 also in meters. So if I add these two together, I'm going to have a 1.29 plus 3.19. This will give me 4.48 in meters. It means I have along the x-axis I have this one, along the y-axis I have this one. The next thing I will do is to get the resultant of these two. The resultant of these two in magnitude and direction will be the answer I am asked to find. Okay. Now the question is, how do I get them? I will have to draw another xy plane, and in that xy plane, the vertical, since s of y is vertical and is positive, as we can see, so it will be directed along the positive y, and then this one is negative, is horizontal x, so we will direct it along here, and then we will now draw our resultant vector and calculate it. We will do it on the next page. Now the next thing we are going to do is to draw our xy plane. Okay. We will draw it in such a way that we need the plus y and the negative x, because our s sub y is positive, you see. So let's bring that. Our s sub y, you see, is positive, so we draw it along the positive y plane. So I'm looking for this plane. I like it very much. So we have this one here. Okay, this is y, this is my s sub y. Okay, now, and I see that you can also bring it here. So for me, I prefer, instead of drawing it here, I prefer drawing it here, because at the end you will have all your vectors together. So I'm going to draw it here. Okay, this is my 4.48 meters. You see, 4.48 meters. And the other one, s sub x, is negative, right? So we draw it along the negative. We know this is x, this is plus x, and here is negative x. So it means our vector is here. Our vector is here. Okay, our vector is here, and you have 90-degree angles here. So the resultant, this vector is 0.88 in meters. The resultant of these two vectors, we can draw the resultant from the tail of the horizontal vector to the head of the vertical vector. So we draw this all the way to here. So this is our resultant, and we are going to call it vector S. Vector S is the resultant, and the direction, remember in the problem they said that it is measured relative to the plus x axis as is customary. So this means the direction of this vector is from here all the way to here. You see that? All the way to here. Now to find this direction, we need to know this small angle first. This angle, we can call it theta. Then to find this one, we will say 180 degrees minus theta, because the complete angles here, first quadrant plus second quadrant, is 180. So if this is theta, the remaining part will be 180 minus theta. Having said that, how do we find the resultant of the magnitude of the resultant? Because the resultant can have direction, it can also have magnitude. So to find the resultant magnitude of the resultant, we say the magnitude, this is how you write the magnitude of the resultant, squared, is equal to s sub y squared plus s sub x squared, meaning you will apply Pythagoras theorem, since you have a right angle triangle here. Hypotenuse squared equals opposite squared plus adjacent squared. So your s is equal to square root of s sub y plus s sub x squared, everything square. Okay, if you take the square root of both sides, the square root here, this square will cancel the square root, and here the square root remains. So this is equal to, now you substitute, and you have square root of your s sub y is 4.48 squared plus here you take this one, this is 0.88 squared. Why did I ignore the minus? Because the reason is that if I have minus 0.88 and I square it, it means minus, this is rough work, it's not part of your solution. It means minus 0.88, okay, times another minus 0.88, and minus cancel minus. Okay, this would mean minus cancel minus, this times this, it is identical to 0.88 squared, and this is why I just leave it as 0.88 squared. Okay, if you are squaring a negative number, let's say I have minus 2 squared, this means minus 2 times another minus 2, and this is identical to 2 squared, because at the end you will have 4. Okay, but if you have minus 2 squared, is different. It means minus, open bracket, 2 times 2, so that at the end you have minus 4 and the negative survives. They are different things here, but what I have here is this one. Okay, you open bracket, close bracket, and square it, and it's identical to ignoring the negative sign and just squaring. Now, having this one, how do I simplify? How do I get the result directly? What you will do is, if you are using this CAPEC calculator, the Y calculator popularly known, what you will do is that, remember this part, I am doing the rough work for you. You just press square root. If you press square root, press open bracket.
When you open the bracket, press 4.48, this very one, and then press the square. There is square function, you know it. Press that one, then plus 0.88, press square again, close bracket, and then press the equality sign. You will have the result directly. The significance of this bracket is that with the CAPEC calculator, if you press square root and then you just press this one without this bracket and you square it, then you say plus, all of it will only consider this one in the bracket, and this one will not be regarded as part of what is inside the root by the calculator, and as such it will give you a wrong value. So always remember that while calculating, so that you will not make a terrible mistake, because at the end you will have a wrong answer. Okay, let me press that and see what I will have. So square root is here, then I have open bracket. You see it's coming out here. So I have my 4.48, then squared, plus 0.88 also squared, then I close bracket and now press my equality sign, and I have 4.565. I have to correct to one decimal place. This should be 4.6 in meters. This is the magnitude of my vector. Now how do I find the direction of the vector here? I need to know this small angle, and the angle has to be positive, and if I want this angle to be positive, I have to ignore the negative sign here. Okay, to get the angle, remember this is the magnitude of my vector, and I will go on to find the direction. This the side facing this angle is this side, so this is opposite, and then this is my adjacent. So I was opposite divided by adjacent is tan, so I will say tan theta. The tangent of this angle is given by what is vertical here, which is s sub y, divided by what is horizontal, which is s sub x. Okay, and I know that my s sub y is 4.48 divided by my this will be 0.88. Remember, we need positive angle, that is why we ignore the negative sign. So my theta equals tan inverse of what I have here, 4.48 divided by 0.88. Okay, so you now bring your calculator and do it as quickly as possible. Okay, now to use tan inverse, you have to press this function first, shift. Okay, if you press shift, then you press tan. Here is tan. You can see tan inverse appears. Then you now open bracket and then write your denominator, your numerator 4.48, then divided by your denominator 0.88. Okay, then you close the bracket. When you do that, now press the equality sign and you see the result. This is 78.888 approximately to the nearest degree. This is 79 degrees. Now that we know this theta, remember our theta is this angle and is 79 degrees. To get the other one, you just say therefore your angle for the vector is 180 minus theta, and this will give you 180 degrees minus 79. You just found your theta as 79 degrees. This is 101 degrees. So you have the magnitude of the vector here, and this one is the vector direction. Okay, now you can combine your result and say therefore your s vector, which is the resultant, because here we say this is our resultant. Okay, the resultant is, you now write the magnitude of the resultant. You obtain the magnitude of 4.6 meter, 4.6 meters. Then you now give them the direction. Your direction is 101 degrees, and you have to specify how you got the direction. You say from plus x axis, so you now say from plus x axis, because that's how you took the measurement. This is the magnitude of the resultant, and this is the direction of the resultant. I hope this solution is clear to all of you. If you are confused anywhere, if at any point you begin to feel lost, please write the question on the comment section and I will respond it, inshallah. Thank you for watching. Assalamu alaikum wa rahmatullah, and goodbye for now.